Hi all, welcome to the fourth part of the video lecture on relational algebra. So in the previous parts like part 1, 2, 3, we discussed in detail what is this relational algebra, what are all the relational algebraic operations, relational algebraic expression, and we gone through the operations like a select, project, and all the binary operations, set theoretic operations like union, intersection, set difference, Cartesian product, and last video lecture we discussed in detail a very special operation called a join and variations like a inner join, outer join, like that many things. Okay, eq join, theta join, etc. Fine. Now it's time for us to conclude the concept that we discussed so far. So before that, let's just introduce a small topic here. So what are all known to be the complete set of relational algebra operations? We saw a number of operations. Hope you remember: select, project, union, intersection, etc. And out of them, these 5 operations, not 5, these 6 operations. So what are they? This is a select operation, right? Select, and this is our project operation. Then we have this union, and this is something known to be the rename operator. Rename, I already told you, we didn't discuss this in detail, but just to rename some of the attribute names we can use it, right? Similarly, this is our set difference, and this is our Cartesian product, right? Cartesian product. So these 6 operators are known to be the complete set of relational algebra operation. In the sense, using these 6, if you have these 6 operations or operators with you, you don't need any other operators. In the sense, any other operation can be say simulated using this set of operators, something like that. Okay, so it has been shown that the set of algebraic operation, that is select, project, union, rename, set difference, and Cartesian product, right, is a complete set. In the sense, that is any of the other original relational algebra operation, we studied many others also, right, that can be expressed as a sequence of the operations from this set. For example, one operation which is missing is intersection, right? The intersection is not there in the sense set because we can express intersection using some of the operators from the set. For example, intersection can be expressed as union of these two things, set difference, this r minus s, set union s minus r, this thing, right? So just look at the Venn diagram, you can see that what we are interested is, this is your r and this is your s, and this area is what we call as this r intersection s. Okay, now how can you express this? This is something like a okay, let me take another one. So it is something like from this r and s, what you can do, just take the union. So if you take the union, you will get the whole thing, right? So this whole thing you will get, and from that union you remove r minus s. So this is your r minus s, you remove this, and this also you remove, that is s minus r. So once you remove that r minus s and s minus r from the complete one, I mean you are supposed to remove this part and you are supposed to remove this part, right? So when you remove these two parts, what remains is that intersection part, right? This I think you don't need an explanation for this because you already know this, say from our so finally what remains is this area. So this is your r minus s and this is your s minus r. So what you done is, from r union s you are removing r minus s and s minus r. What remains is the r intersection s. So you expressed this intersection as using union and set difference operator. Similarly, another popular operator, we have this what is called join operation, right? So join operation is typically we have a join condition. Now what you can do is, you just take the Cartesian product and apply the selection. So that is same as this join operation, right? So this is very important. We already know join is nothing but Cartesian product followed by the selection operation. So selection operation, this selection condition is to be written means like subscript. Okay, so that is fine. So here it is not like that. Okay, so what we mean is like so let me write it here. I want to find out the or I want to do the join operation for between r and s using a condition c. So this is nothing but, or this is equivalent to, you just take r cross s, the Cartesian product, then you apply sigma over this condition across it. Okay, so both are same. So that is Fine. So we don't need that also. So you can express this join operation as a using Cartesian product and a selection operator. Fine. So similarly, a natural join can be natural join. You know what it is. So equijoin with that duplication is removed, right? So Cartesian product preceded by a rename. So now it shows the importance of rename. Natural join will work only with the rename, right? So you have to rename. Then with the common element, it will do that join, and the repeated things will be removed. So rename followed by Cartesian product followed by selected project will do this natural join. Okay. So that about it. So the conclusion is so just remember this selection, projection, select, project, union, rename, set difference, and Cartesian product. These 6 operators together known to be the complete set of relational algebra operation. In the sense, any other relational algebra operation can be expressed using them. So this is something like a functionally complete set of operator that you studied in digital, right? Say and, or, and not, using which you can implement any other function like an and, or anything. Okay, so digital operators you studied, right? Boolean operators. So something similar to that. Now this is a complete set that we gone through. Just a quick review. You can just summarize the things so you know what is select. I'm not going to read it again and again. It is a horizontal partition, right? So this is a general notation. And project, which is a vertical partition, the attribute list you have to highlight. And join itself, we have theta join for without, so that is a general form of join without any specific. It can be comparison, it can be equal condition greater than less, and everything will involve. So if the join condition involves only equality, I mean it will do only this equality checking, we can call it as an equijoin. Now a variation of equijoin where the duplications are removed and the rename is to be done is what we call as a natural join. Then union operation, you know, union, intersection, because relation is a collection of tuples, right? Set of tuples. So within a set we can apply all these operations just like that. Here also we can do that. And Cartesian product. Okay, and finally join. So now there is one more operation called division. As it is not highlighted in the syllabus, I didn't explain it so far, but anyway I just taken on example on a relational algebra query where that division is involved. I will just tell you, but as it is not highlighted in the syllabus, I didn't explain throughout the lecturing so far. Okay, fine. Anyway, division is something important also, so even though it is not there in the syllabus, it is better to spend time on it. Okay, so something similar will come in SQL also. That time you should know how it is to be done. Yeah, so now let's go through some of the examples from the textbook only, like some queries and how it can be written using relational algebra. So for a practice, so in general in exam they can give you any query like this and you should be able to write the relational algebraic expression. But at the same time here we are taking the default assumption that we are referring that company database. Hope you remember company database. Okay, so with the tables like employee is a table, right? And there is something called as the department table is there. Department, and another table was project, right? Project, and there is something called as dependence. And then for the multi-valued attribute, say works, employee works on project, we made a table. Hope you remember, because it is a many-to-many relation. For many-to-many relationship, when you are mapping it to relation model, there will be a new relation for it. And similarly there is something for this department locations also, because it is a multi-valued attribute. Okay, so these are all the relations which are available in our database system. So now and you hope you are familiar with the attributes also. If you don't know, please refer the lecture on relational data model, and particularly that mapping from ER to relational model. There the complete structure is given. Okay, so our most of the examples were referring that one only, because I am following that Navate Navate textbook from, so they are basically preparing the theory in that way. Okay, so in generally in exam they can give you anything. Okay, so that time they will clearly say what is the database, what are all the entities, and what are all the attributes, and accordingly they will form questions like this. Okay, so now what you want is like retrieve the name and address of all employee who work for research department. So it's a very simple query. So so how many entities you have to refer here? See, you need the details of all employees, right? So you have to refer the employee table, of course, who are working in the research department. So department table also you have to refer. So from the department table, select all departments with the name research. Okay, So basically this department name is a unique attribute, I think. So that was our requirement. If that is the case, there will be a single department with the name research, right? Now what you can do, you can take that particular department. Okay, so the full details of that department, say research is here. So when you are taking the row corresponding to research department, you will get the department name, the manager SSN, the department location, like that many things you will get. Locations may have a different table, but still, yeah, okay. So this is a complete information, right? Now from that, what you are doing is you are doing Cartesian product of this particular result with the employee table. So actually you are trying to make that, I mean, Cartesian product followed by the selection condition, that is nothing but the join operation. So now you have to join the employee table with the department table. You got it, right? Why we have to join? Because we are supposed to answer the name and address of the employee who are working in or who are working for department research. Okay, so if you are looking at research department is a single department, of course, but there may be n number of employees working on it, right? Now the employee table will be having details of the employees of the all departments of the organization. For example, suppose there are 1000 employees, and if you are looking specifically at the research department, the research department is having, say, only 100 employees. Say, I am just taking an example. There are 1000 what called employees totally, and 100 of them are working in research department. Now what you have to do is you just we need details of those 100 employees only. So here we are doing this, so that is what we are trying to do. So when you take that Cartesian product between this particular department row and the employee table, the complete employee table, you will get all possible pairing, and out of them, those with the department number is equal to DNO. So DNO is a field in employee table, and D number is a field in department table. So when you take the details of particular department having with the named research, you will get a D number of that department, right? So D number of the department and DNO of the employee table is acting is equating. So we have a equijoin, and those which are having a match is finally coming out. Okay, hope you are understanding, right? So employee table and department table are joined with respect to the common attribute, or the, so that common attribute is nothing but this D number act as a primary key in the department table, where DNO act as a foreign key in the employee table. So always this joining by default, when you come to combine two or more tables, you will be combining with respect to this common attribute, which is a primary key in one table and a foreign key in another table. So you are doing this comparison. So we taken very fundamental examples for this, and I already explained you how this join is working. If you have any doubts still, please watch the previous video so that you will understand. Okay, so what is happening? So it's not possible to take exact example here also. So hope you can visualize it, right? Yeah, that's all what we need. Okay, now you got the matching pairs, right? And from that you are interested on name and address only, right? So you just have to retrieve the name and address. So from the result you got, you just project the first name, last name and address. Okay, yeah, so like that in a 3 steps you written there. Same thing, if you want, you can write in a single step also. So here we are splitting and writing. So I think this is a good practice. And if you want, what you can do is like you first to do this say department and employee table fully you are joining with respect to D number is equal to DN, and from that you are taking information correspond to department name is equal to research, and from that you are projecting first name, last name and address. You can either write like this or this. Okay, yeah, that's all. So now the second query is like so just read the query and try to answer without looking at the solution. So it's the same thing, you know, you can answer it in a number of ways. So it's all about which method you are using. Okay, so just read it and try to find solution. Okay, so in this query what they are asking is, for every project located in Stafford, list the project number, the controlling department number and the department's manager's last name, address and birth date. See, here you have to, first you have to, what you have to understand is like how many tables or how many relations you have to refer. You have to refer the project table, then only you will get the project number from there, right? Now the controlling department number they are asking. Okay, so controlling department number may be available in project table, but still what we need is controlling department's managers details also. So from project table you have to establish a join with the department table, right? So that from department table you will get the manager's social security number. Okay, so that only is available in department table, only that SSN. And now you have to refer the employee table also. See, employee table also. Now from employee table by matching the social security number, you will get the details, further details of the manager, like what is his first name, last name, address, birth date, etc. So 3 tables are to be referred or joined. Okay, so the first join is between the project table and the department table, and that you can directly make have this join, or what we are interested, select those tuples and then do the join. So that is what is done here. So we are interested only on the project located in Stafford, right? So project location was a single valued attribute, so there is no confusion. So it is simply maintained as an attribute in the project table. So from the project table, have this condition, selection condition, project location in Stafford, and take the details of the projects, how many projects are there in Stafford, take them. Okay, so that result you are joining with the department table. Now if you want, you can directly make the join between project and department, then you can apply this condition also. But this is something good practice, because now if you are directly taking project and department table join, in the sense the Cartesian product, see how many entries will come. But now you are filtering and you are focusing only on the projects located in Stafford, and that you are getting doing some kind of eq join with the department. And the join condition is dnum is equal to d number. Dnum is the attribute from the project. I mean, in the project table, the controlling department number is stored with an attribute named dnum. Okay, where in the department number, unique ID is d number. So actually this dnum is the foreign key in the project table, and d number is the corresponding primary key. So always we are doing join with respect to that, and equating them, we have that join condition. So this will give all the department details of the projects which are located in Stafford. So the first step is over. Okay, now you have to make it. So now you have a bigger list. So if you are looking at controlling departments, so something like this, if you want, you can just write some t1 t2 also, find some temporary variable names only we need, or you can give it a meaningful name like that. So now this controlling department something, so this particular relation is containing all details of the project as well as department which are located in Stafford. Okay, now that result you are again joining with the employee table. So this is like a employee, so this should come here, employee table. Okay, and now you can see that why you are doing like that, because in project we have details of the project, department we have details of the department, and there is a one attribute called manager SSN. Now this manager SSN field of this department table is equated with the social security number of the employee, so that you will get the details of the person who is managing the department which are located in Stafford. Fine, sorry, so the details, so what my statement was wrong, listen once again. Now you will get the details of the employees who are managers of the department, and the department is acting as a controlling department for the projects which are located in Stafford. So that is a kind of relation we made. Okay, so from project relation we identified all the rows which are in Stafford, then we combined them with the department table, so we have details of the projects and the controlling department details fully. Now from that we are taking the manager SSN and we are equating it with the SSN of the employee table, and we are joining them. Now you will get the details of the employee who is a manager of this controlling department of the project located in Stafford. And what are the information we need finally? Okay, so this is one crucial step, like combining project and the controlling department. Now this is another crucial step where that result is getting combined with the employee table, and finally what is needed is a project number, department number, last name or first name, what are all the things they are asking, only last name. Okay, address and birth date of the employee who is a manager of the project which is located in Stafford. Okay, who is a manager of the department which is controlling the project which is located in Stafford. Okay, so now it is a kind of three-way join. Okay, so that is what you can see. Now the third query, so this also you read it, pause for a while and try in your own way and check the final result. So don't look at the solution. Okay, try it in your own way. Okay, fine. So find the names of the employee who work on all the projects controlled by department number 5. So now this here it involves a concept called division. Anyway, I didn't explain division as it is not given in the syllabus, but I find this query interesting. So with the help of this query I will try to explain what is division. Okay, and if something is asking like all, typically we have to use this division concept. So that is one way you have to remember this. But anyway, I don't think so, as it is not directly given in the question something, but we can't predict. Sometimes they may ask such a question, and maybe as part of relational algebra you are supposed opposed to no division also. In that way they can frame questions, but still it's better to know on the concept. Okay, so let's just explore this question. So what we need is find the names of the employee who are working on all the projects controlled by department number 5. So what is your first thing you have to do? Look at the department table, right? And no need to look at the department table. See, because we are just looking at the department number field only. Okay, and this department number field we have in the project table also. Okay, so and we are just in need of employee details also. Yes, we need name of the employee, so we have to refer the employee table for sure. And we are talking about the projects controlled by department number 5. So in the project table we have the controlling department number we are saving, right? So that is that DNum field. So from the project table you can take the details of the project which are controlled by department number 5. Okay, so project table is needed. Okay, and once you get the details of the project which are controlled by department number 5, for that you need only project table. Now you refer the employee table, but before that the kind of relationship we have here is employee. So let me write employee like this. So hope you remember this kind of a relationship in your diagram. Works on project. Okay, so this was our relation, and what we done is like this was a many to many relation, right? And in that case what we done is we made a relation for this employee table. There is a relation. Okay, I'm not writing everything. This is something we saw already. So there is a relation for this this employee entity is mapped to a relation. So let me call it as relation 1. Say employee relation. Project is mapped to a relation. Okay, and this works on relationship also we mapped to a relation. So this is a relation 1, 2. So there were 3 relation for that. So there is a relation called works on. Okay, so from that works on relation, so this is what is capturing this relationship. So if you want to know which are all the employee working in a given project, you have to look at the works on relation. If from employee table you will get the details of the employees, and from project table you will get details of the project, right? And which employee is working on which project, that is maintained in a different relation or table with the name works on. So you have to refer this works on relation, then only you will understand which are all the employees working on a given project. So this is something I am removing because it's not so important. I just want to recollect your memory. Okay, something we already discussed. Okay, now what we are interested is, hope you understand, right? So we have to refer works on relationship to get the relation between employee and project, and project relation. From that you will understand what are all the projects controlled by department number 5. Okay, so first step is like we are referring the project table, and we are taking a selection condition as department number is equal to 5. We are taking details of the complete details of the projects which are controlled by department number 5. Okay, now from that you are projecting just a project number only, because that is enough, because we just want to know the name of the employee who are working in all projects controlled by department number 5. So okay, so we don't want any other details, so simply focus the project number of all the projects controlled by department number 5. So department number 5 projects you are selecting, then you are projecting the project number alone, and in the project table project number is stored with the attribute name P number. Okay, now we are renaming it to PNO, so that I will tell you why. Okay, so we will see it soon. Okay, so why we are renaming? So anyway we are renaming. So finally what you are getting is you will get an attribute PNO. So that is only projected. Actually you projected P number, but later you renamed that P number to PNO. Okay, and this is going to contain the project numbers of the projects which are controlled by department number 5. Assume project number 1, project number 2, project number 3. These 3 projects are controlled by department number 5. Okay, assume these are all the projects. So let me write projects controlled by department number. So department number we have a field DNum, right? DNum equal to 5. Okay, fine. So let it be. Okay, assume so. Assume. Now what you are doing is From the work zone relation, I don't know whether you remember work zone or not. Work zone relation is containing, so that is just for establishing that work zone relationship. So the primary key from the employee table, that is SSN, which is renamed to be ESSN. Then project number of the project number PNO is a renamed version, actually P number, okay, which is a primary key of the project table. So those two things will come, they together act as a primary key, and number of hours an employee is working per week, that is also we are storing in work zone. So work zone relation, just for you to recollect, this is something, okay, so it is having a field called employee SSN and project number, and there is something called as hours also, and these two things together act as a key, and they are foreign keys also to the employee table and project number table. So something like this is what we are having, and from this we are not interested on hours and all, we just we are interested on employee SSN and PNO. Okay, so those two things we are projecting, and again we are renaming them to SSN and PNO. Okay, so we will see why this renaming is done. So let me write. So now what we have is SSN and PNO. Okay, now these two things are having same name. Okay, so something some renaming, so ultimately what we need is this name and this name should be same. So that is one reason. Okay, if you want, you can if you can treat it as P number, and this you can rename as P number, that also fine, anything you do. And SSN, why we are using is because finally from this result we are referring the employee table, and in the employee table the field is having a name SSN, so that is why this is renamed. Okay, anyway we will see. So from the work zone relationship, we as we already know, we have details like say employee number 101 is working on project number 1, say this many hours per week, like that we have information. So from that we are filtering only ESSN and PN. Suppose I am randomly writing employee number 101 is working in project number 1, and say same employee, I mean let me write together, or you can it can be random also. Say employee number 2 is working on project number 1, employee number 103 is working on project number 2, employee number 101 is working on project number 2, 101 is working on project number 3 also, 103 is working in project number 2. Randomly I am writing 102 is working on project number 3, and 103 is working on project number 3. Say 104 is working on, randomly I am writing project number. So it can be some other project numbers also, project number 4. So this will contain of complete details, right? So 104 is working on project number 5, like that anything can happen. So suppose this is the current set of attributes. Okay, so this is the current set of attribute. Now what we will do is we will do a division between this result and this result. Okay, so division is done between these two. So this is one set of information I am having, this is another set of information I am getting. I am going to do a division between these two. Okay, now what this division is going to do is simply this is going to give you this all information, right? So what we are interested is we are interested on the details or the name of the employee who are working in all the departments controlled by department number 5. All the project controlled by department number 5. So we already know what are all the projects controlled by department number 5, that we already selected, that is P1, P2 and P3. Now if there is a employee who is working on P1, P2 and P3, I want his name. And here by observation you can see that 101 is such an employee, because 101 is working on P1, P2 and he is working on P3 also. Okay, yeah, so that is one candidate. So division is something, that one only. Yeah, what it will do is it will look for a mapping. So this is to be completely divided, something like that. So here I will get this P1 corresponding to 101. Here I will get this P2 corresponding to 101. Here I will get a P3 corresponding to 101. And from that you can see that the P1, P2, P3, they are divided, right? And the quotient is something like quotient, we are getting it as 101. So 101 is something having relation with the P1, P2, P3. So when you are dividing, this 101 is a candidate that is going to come in the final result. So after doing this division, the result of this division is going to contain SSN alone. Okay, because this PNO is getting divided, right? So SSN alone. So 101 is going to be a candidate. Now what is the next candidate? If you are looking at P2, you know P2 is getting mapped with the sorry, 102 is mapped with the P1 and 102 is mapped with the P3 also, but unfortunately 102 is not mapped with the P2. So because of that 102 is not a candidate. Okay, so 102 is not a candidate. Now the next candidate is, see, another one is like 103. 103 you can see P2 information we are having here, 103. So let it be P1. Okay, so I mistakenly written like that. So 103 is mapped with the P1 also. Same 103 is getting mapped with the P3 also. Fine. So if that is the case, 103 is getting mapped with the P1, P2 and P3. So 103 is going to be a candidate in the final result. Okay, so this is the final result. Now if you are looking at 104 is there, he is just mapped with some other project, that's all. Okay, so those things are not going to affect the answer, final answer. So the final answer is 101 and 103, and by observation you can see that these are all the employees who are working in all projects, that's P1, P2 and P3, which are controlled by, say, department number 5. So this is the purpose of division. Now you understand, right, how division is working, that's all. So it is a very important thing. So whenever you are having a question like this, this is how you can answer it. Now once you get that result, this SSN you have to further, so now you have the social security number of the employees only, but what we are interested is the name of the employee. So to get the name of the employee, you have to refer the employee table using this SSN. So for that you can do this natural join. So why we renamed as SSN? It's because we want to apply natural join. So when it is natural join employee table, we have this field SSN, and now this result is also having the name SSN. So by default when you do this division, SSN PNO divided with the PN, now result is having attribute name SSN only. And okay, so with respect to the SSN of this result and the employee table SSN, it will do equijoin. So that will done automatically as I mentioned this natural join. Okay, so that's all. From that result, just project the first name and last name. So that's all. So now hope you understand the division operation with this one. So that is actually important, but anyway, as it is not highlighted in the syllabus, I didn't explain it in a separate way. Okay, anyway, I hope you understand how it is working. So now the fourth query is like make list of the project numbers for project that involve an employee whose last name is Smith. Okay, the last name of the employee has to be Smith, either as a worker or as a manager of the department that controls the projects. Okay, so Smith, either he can be a worker or he can be a manager of the department which controls this project. So basically a project table is involved. Okay, because you want to make a list of the project numbers. Okay, so from project table only you will get it. Now you have to relate it with the department table, and then only you will get the controlling department information, and then you have to take the manager ID and you have to see whether it is Smith. Okay, somewhere as a last name. Okay, so last name is to be Smith. So there are two things coming. So one thing, so either or, something like that you can see, right? So or, if or is coming, by default this union operation is involved at some point. Okay, so first you can find out the first part, then you can perform union with the second part. So what is your first part? So what is asked in the question? Or I can write it, this will help you, right? So you want the list of the project numbers for the project that involve an employee whose last name is Smith, either as a worker. So first we will look at the project numbers where Smith is a normal employee. Okay, so that you can find out from work zone, because which employee is working on which project, that is captured by the work zone relation. Now see, work zone relation is also involved. So work zone relation, employee, department, finally, so all those things are involved. Project also, because project number is finally asked. So 4 tables are involved in this query. So that you have to. So why work zone came now? Because we want to know the employees who are working in a project. If the name of the employee is ending with like his last name is Smith, then we need his project number, right? So we have to list project numbers for which Smith is a employee or Smith is the manager of the controlling department of the project. So like the two things are asked, right? Either or. So that is why in between union is coming. So first we will find out what details of the project number where Smith is a normal worker. So that we will be getting from work zone relations. That is why work zone is keeping track of employee and he is working on a given project or not, like that information. Now we need to know the manager. If the manager last name is ending with the Smith, okay, so employee table, manager SSN from department table and project, so like that. So that is the second set of query. Such a people project number we will trace, and both of them finally you will union. Okay, so you understand that there is union. So now let's proceed step by step. First, what we are doing is, from the employee table we are looking at the details of the all employees whose last name is Smith. So why we are doing it immediately? Because employee table is a very huge table, so it is always better if you filter the table. I mean, you simply partition the table in such a way that now you are having details of the all employees whose last name is Smith. So with respect to that, you are going to find out the project number, everything, right? So that you done, and you are storing in Smith's employee SSN, something like that, this kind of a table. So here this SSN you are renamed to employee SSN, ESSN also. Why? Because ESSN is the attribute field that we are storing in work zone relation. I already told you this work zone relation is containing ESSN, PNO and hours. So SSN from the employee table you are renaming to ESSN, or you can do in the opposite direction also, whatever it is. Finally we have to do this natural join. For that we done this renaming. So now SSN is ESSN, work zone is also having ESSN. Now using that ESSN, by equating it, this natural join is nothing but eq join with a common attribute, right? It will equate these two, and from that you will get the project number of the project where this employee with the last name Smith is working. So Smith tables tuples we are taking. So all tuples with the last name as Smith we are filtering first, then we are joining it with the work zone relation. Work zone relation will contain project number, employee number and number of hours, like that. Okay, so project number we want, right? So for that we done this natural join. So now you are projecting the project number where the Smith is working as a employee. Smith in the sense last name Smith. Okay, so these two things will do the first part. So now we got in Smith worker project, we got the details of project number of projects where Smith as the last name, where the employee with the Smith as the last name is working as an employee. Now the second part is about the manager, like this last name as Smith should come as a manager of the controlling department of the project. So this involves some 3-step procedure like that, because this project table is to be merged with the department, then it is to be merged with the employee. So these things should happen on the background. So what we done here is, first this employee table and department table are joined with respect to SSN is equal to manager SSN. So now we are getting the details of the all employees of all departments. So as department is a small table, you can do this, no problem. Department table will contain details of the departments only, right? Maybe some 10 or whatever it is, how many departments are there, we have details of all department together with the details of the manager. So that manager SSN using SSN and SSN from the employee table and manager SSN from the department table, which is a foreign key, we are doing this join, and finally you will get details of all departments and employees who are the managers. Okay, now from that you are just projecting the last name and department number. See, because we have to check it against Smith as a last name, so that is why we are projecting last name, and the department number also we are projecting. So finally, so this is a very big set which contains details of all employees who are managers, followed by the department details. Now from that, the name of the employee, not the complete name, the last name and the department number, those things we are projecting and we are keeping here. Now what you will be doing, just to do a selection from this result. Okay, so if you want, you can combine everything also, fine. Otherwise do in a step-by-step manner, this is always better. So the last name you are checking against Smith, and okay, so once you are getting a match like last name as Smith, so here you will get the details of all employees, right? Last name, D number, everything you will get. Only the Smith related things you are matching. You can write it in a different way also. I think you may already get in different ways to answer the same question. Okay, all are fine, just you need a solution, that's all. Okay, yeah. Those whose last name is Smith you are filtering, and from that this D number alone is projected. Okay, so D number alone is projected because now this D number as a controlling department number, you have to merge it with the project table. Okay, so the now you got the department number where the manager's last name is Smith, that's all. Now in this step what you are getting the department numbers where manager's last name is Smith. Okay, so that is what you obtain now. Now this result is available in some variable like this is getting what is called a natural join with the project table. Okay, so because finally you want to know the project number information of those projects for which the controlling department's manager last name is Smith. Okay, you got it right. So in that natural join you are doing, so when you are doing this natural join with respect to project table, we have dnum as a department as a foreign key, right? So that is why you are renaming this result into dnum here, so that this natural join will automatically take the dnum field of project field and dnum of this, as both are having the same name, it will do that eq join, and from the result the project number alone is highlighted. Okay, so these three steps together will give the project numbers where this Smith as the last name, that particular employee is working as a manager of the controlling department of the project. Okay, so this is the first part and this is the second part, right? So this will give you the details of the project numbers where the last name as Smith, that particular employee is a normal worker. Here this will give you the last name as Smith, that particular employee is a manager of the controlling department of the project. Now these two things finally you can union and that will give the final result. Okay, hope you get it. Slightly confusing, but it is actually easy once you understand clearly and you practice on different question, you can write it nicely. Fine. Okay, some few more queries. The next one is list the names of all employees with 2 or more dependents. Just employees with 2 or more dependents. So now there is some kind of counting involved, right? So from the department table you have to focus on employee having number of dependents 2 or more, like that. So whenever there is a counting, we have to use another relational algebraic operator called the aggregate function. Again, we didn't discuss aggregate function so far, because in relational algebra in your syllabus this is not highlighted. Okay, I will show you the syllabus. So why I am moving like this? So 1 second. Yeah, this is your syllabus. See, when you look at the second module, so they are highlighting the select operation, project, Cartesian product operation, right? All those things we saw in detail. Then join, here eq join, natural join, maybe other types also I discussed. Only this many things are given, that is why I didn't explain, as they are given the name and division, aggregate function, etc. But anyway, this aggregate function aggregation will come when we discuss that SQL, more details of SQL in your third module. Okay, so that time you will understand that operation, but in relational algebra it is not specifically given. Okay, so that is the reason I didn't discuss. But anyway, just for completion I taken this query also. I will just tell you, just like a division I will explain what is the aggregate function. So it is nothing but this kind of a symbol is what we are using in for representing aggregate functions in relational algebra. Some notation like this. Okay, and what you have to do is you are grouping, in the dependent table, what are all the informations in dependent table? Dependent table, we have a field called employee SSN, in the sense social security number of the owner entity. Okay, so that we are storing. Then the name of the dependent, right? Dependent name we have, and some other information like address, etc. There is something called as a relationship with the strong entity, like that. Many informations we are having. Now what you are doing is this, if you are looking at this employee SSN, employee number 101 may have a dependent 1, the same employee may have a dependent 2 also, right? So we need 2 or more. Okay, so this employee is having 2 dependents. Now if 102 may have only one dependent, we don't want him. 103 may have a dependent 4, 103 dependent 5, same 103 is having dependent 6, so like that. So now what you have to do is you just group this by something like the employee SSN. So that is how we are writing for this aggregate function. We are going to use this count. So we are just counting the number of tuples and we are grouping with respect to employee SSN. So with respect to employee SSN group, so you are getting this kind of groups, right? Now once you get the group, just count the dependent name. So you can see in this group how many dependent names are there? 1, 2. So here corresponding to 101 I am getting the count as 2. Now corresponding to 102, I am getting the count as only 1, right? Only 1. So you are just counting the dependent name corresponding to that particular group. Okay. Now corresponding to employee SSN 103, when you are grouping it, you will get the dependent name count as 3. So like that you will get the information. Okay. Okay. So this is our employee SSN and this is a count. Okay. So this result which is a count is something that is stored inside the variable what number of dependents. So they are giving a name like this. For this field they are giving a name like a number of dependents. So that is what we counted, right? Dependents. And the other one they are renaming to SSN. Actually it was employee SSN, it is renamed to SSN. So you are getting something like this. Now again there is a selection criteria by which you are selecting all the tuples as from this temporary. So this whole thing is stored in some T1. Okay. Now from this you are selecting those with this number of dependent, that field greater than 2. So greater than thing with 2 or more. The list the names of all employee with 2 or more, so that you can use greater than or equal to, no problem. So this will be selected and this also will be selected. Okay. Okay, that's also. Now you have 101 and this 2 says that it is having 2 dependents. 103 says that it is he is having he or she is having 3 dependents, like that. Okay. So now you got the info details of all SSN for whom the number of dependents are greater than or equal to 2. Okay, now finally you have to do a natural join with the employee table. So as you are doing this natural join, this is something renamed to SSN, because in the employee table we have this SSN as the primary key, and here also we have this SSN and other fields. So when you do this again, so this will be equated like or not one, like that it will do. Okay, and finally from the employee table you will get full details of the employee, right? Actual employee, and but we are interested only on the name, so that you are printing first name and last name. Okay, projecting. So that's also here that aggregate function, it is typically represented like this with respect to which attribute you have to do this grouping, say ESSN, and what you have to do is count. Sometimes you want to add, like that you can mention any operation. So dependent name you have to count here, that's all. Whether you want to do some average, all operations are there. Actually they are summarizing things. Okay, so so out of these we are summarizing, like the count is 2 1 3. Sometimes we summarize like the sum is like that, average is like that. So all these are aggregate functions. So some kind of aggregations they are doing. Okay, so here it is counting. Yeah, that's all. And then you are checking against count is greater than or equal to 2. Then finally employee table you are doing a join, natural join, or some other join you can apply, and the results are projected. Now the next query is retrieve the names of employee who have no dependents, who are not having any dependent. Okay, so it is quite easy actually if you think about it. This is something that you can solve using set difference. Okay, the minus operator. So you may be trying in different ways also, but it is better to do because why it is. So retrieve the names of the employee who have no dependents, right? So what you can do is from the employee table you can take SSN of all employees. Okay, so you are selecting. So now from the employee table, when you are taking SSN of all employees, so one employee, this is SSN of another employee, SSN of another employee, SSN of the fourth employee. Right, like that you will get a SSN. So suppose for the time being, suppose I got to 5 SSNs. Now from the dependent table also you take this, I mean employee SSN. Okay, so if somebody is having some dependent, definitely that owner's SSN will be stored here. Suppose 101 is having a dependent, so that this will be here. Okay, now 102, suppose he don't have a dependent, so that in the dependent table there is no employee SSN stored as 102. Okay, similarly say 103 is having some dependent, that I am storing here. Okay, 105 is also having dependent. 104 and 102 they don't have any dependent, so that there is no entry in the dependent table with the employee SSN as 102 or 104. So this is the result I am getting. Now what I have to do is, I am curious to know details of the employee who don't have any dependent, and there is no dependent. So can you tell me the answer? So what I need finally is, the result I need is 102 and 104, because for 102 and 104 there is no dependent. I just want to know. So to get that 102 and 104 out of it, what you have to do is just to do this set difference. From this set which is containing 102, 102, 103, 4, 5, you do this difference, you will get the result as 102 and 104. So that is what we are interested by. So that's all. So but to do this set reference and all, you have to rename like this SSN, ESSN you can rename to SSN. So that is what you are doing here. Otherwise it will assume the first one's name, so that also there, but still okay, you are doing this rename, and these two results you are doing this set difference here, fine. And once you done set difference, to get so now you just have this social security numbers only. I mean 102, a person with the social security number as 102 is not having any dependent. Okay, so that is the meaning. A person with the social security number as 104. So this is something you got from the employee table. This is something you got from the dependent table, okay, for your reference. Okay, now you have the social security number only. Now you have to join it with the employee table to get the name, because in the question they are asking the name of the employee who don't have a dependent. So now you know the social security number. To get the name, you have to further merge it or join it with the employee table. So now it will work, right, because SSN and those things are matching. And from the final result, the first name and last name is being projected. Fine. So this is a crucial step here. So again, these examples are very nice in the sense it's covering all possibilities, right? So that is why I highlighted these things. Yeah, from textbook only taken. Then one more query, this last one. Say, list the names of the managers who have at least one dependent. So something like we saw before, who have at least one dependent. So there is something at least one. Okay, so some common point as one. Something like that is coming. So you have to do this. You can do this by intersection operator. So, one second, just read it and try to answer. Okay, it's quite simple, just like the logic that we applied before. Here instead of that we are using this intersection, and let's see what is done. List the names of the managers who have at least one dependent. Okay, so from the department table you will get the manager SSN. You can find the manager SSN of all employees who are managers. Okay, so just project the manager SSN from the department table. Suppose out of these people 101, 102, 103 and 4 and 5, suppose this 101 is a manager of some department, I don't know, and 105 is also a manager. Say this is enough, right? And so let me add 2 more people. 104 is also a manager of some department, and 105 is also a manager. Okay, see, that is a case. Now from the dependent table, what you have to do, the employee SSN you are taking. So when you take the employee SSN for all dependents, who is the owner entity, that SSN you will get. So the same example you can take, so that 101 is having a dependent, 103 is having a dependent, 105 is also having a dependent, 101 is having a dependent, 103 is having a dependent, 105 is having a dependent. Now if you are comparing these two, you can see that this 101 is a manager of a department, and also he is having a dependent. That is the meaning, because if he is having a dependent, definitely, so this ESSN you are projecting from the dependent table. Okay, dependent table, and I mean you are projecting. Okay, here you are projecting this manager SSN from the department table, right? So if he is a manager of some department, you will get him as part of this query. If he is having some dependent, you will get him from this. Right now, if you do this intersection between these two sets, can you tell me what is the result? The intersection will give you 101 and 105. What does it say? This 101 is a manager of some department, and he is having a dependent. 105 is also a manager of some department, and he is also having a dependent. Having a dependent means he may have one or more dependents, fine. Okay, and as the project operation is doing the duplicate filtering, even though he is having more than one dependent, that 101 and 105, that will be displayed at once only, because it is doing the duplicate filtering. Okay, but we are interested on details of those who have at least one dependent. So this is enough for us. Okay, so now when you do this intersection, you will get this 101 and 105 as common element. That says that they are managers as well as they are having dependent, or they are having at least one dependent. So that is the result, right? So that is what, so the name of the managers who have at least one dependent, that is what is asked. So we got the result. Now we need the name, right? So now we are having only social security number. As before, you have to finally do that natural join with the employee table, so that you will get the complete details of the employee having social security number 101 and 105. From that you take the first name and last name. So that's also in between, when wherever needed we are doing this renaming. So here everywhere SSN, so that the result is also SSN. With respect to that SSN and SSN of employee table, we are doing the natural join. Okay, so everything you have to be careful and write the queries properly. So we gone through a very good set of examples, right? Some 7 examples, even though they are standard examples covering almost all operations that we studied in our relational algebra. So it is very important, like in exam you can expect some question like whether they will give a description of something, and finally they may ask you just write the query for this. Okay, so you have to know the proper option. So by practice only you will get it. Okay, so that's why this many questions are given. Now also you can go through the questions that are given in the exercise session of your textbook, and you will get the solution manual, and you can you have to spend some time on it. Okay, so then only this art will be developed. Don't expect direct questions. If they can ask something similar to this, okay, from a different context, you should be able to answer them. Yeah, thanks for watching.